Welcome back. Today we're talking about quadratic functions and their characteristics. Let's go ahead and take a look at some vocabulary. So here are some characteristics of our parabola. A parabola is the shape that is made when we're graphing a quadratic. So we've got the axis or line of symmetry that divides the parabola into two equal parts. To find this without the graph, we would do negative b divided by 2a. Our x-intercepts are also known as solutions or roots or intercepts. So they have all the same name, but they are solutions to our quadratic. The vertex is the turning point. It's the minimum or maximum of the graph. Now let's take a look at finding these characteristics. So here we've got a parabola and it wants us to identify the parts of the graph and fill in our answer for each box. So we'll start with the domain. So the domain, if we take a look at our picture, we can see that our arrows are going up and out forever. So they're going to continue to go to the right as far as they can. They're going to continue to go to the left as far as they can. So for our domain there, it's going to be all real numbers, or we can write the symbol for all real numbers, whichever one you are more comfortable with for our domain. Our range, on the other hand, however, is limited. It has a part where it's going to go down as far as it can, and then it's going to stop. And we'll talk about what that is in a minute. But we can see here in our graph that it's going to stop here at -2. So our range can't go any lower than -2, but it is, however, going to continue to go out and up as high as it can. So it's going to go forever the other direction. So our range, we know, is going to stop at -2. So it's going to stop at -2, but it's going to go on forever, so it's going to be positive infinity going the other direction. All right, now our solutions. So our solutions are where it crosses the x-axis. As we talked about, there are x-intercepts, also known as solutions. So we have two of them because it's crossing at two different places. Sometimes it'll cross one time, sometimes it'll cross no times, and sometimes it'll cross twice. In this case, it's going to cross twice. So we've got one of our solutions here between 2 and 3, and we've got one of our solutions here at -0.5. Again, we're going to write our solutions in order from least to greatest. So our solutions, we're going to put them inside our braces, and in this case, we've got -0.5 as one of our solutions, and we've got 2.5 as our other solution. Again, close your braces. Now it's time to identify our vertex, which we did a little bit earlier when we were talking about our minimum here, or where our range was. So this case, we're going to find our vertex down here at the bottom. So it's going to be at the very bottom of our parabola. In this case, it's going to be a +1, -2. We're going to write that as a ordered pair. Now we're looking for our line of symmetry. So again, that line is going to cut our parabola in half. It's going to go straight down the middle and it's going to go through our vertex. In this case, it's going to be x = 1. That is our line of symmetry because that line is x = 1. Then we have to determine, do we have a minimum or a maximum? In this case, we have a minimum, and that minimum is going to be at -2. So we have -2 as our minimum, and we can just write that as -2. All right, now let's take a look at the next example. So here we have another parabola where we're going to be identifying all of the parts. So we're going to start with our domain, and in this case, again, we can see that it's going out to the right as far as it can and out to the left as far as it can. Even though it's upside down, it's still going out to the right and left as far as it possibly can. So in this case, again, we're going to have all real numbers as our domain. Now for a range, again, this time it is going to be limited. Now it's going to be limited differently because it's upside down from the one that we looked at last time, but it still can't go any higher than a certain point. And in this case, that certain point is going to be 6. So our range, we're going to, again, write this in order from least to greatest. So we're going to have as far as we can go up, which is going to be +6, but we can see that our arrows are going to go down forever and ever, so that's going to be -infinity. So we're going to start with -infinity because that's a smaller value than +6, which is as high as we can go. Now for our solutions, again, it looks like it crosses in two different places. So we've got one solution here and another solution here. Again, remember our solutions are going to be our x-intercepts. So in this case, we're going to put them in braces. We're going to write them in order from least to greatest. So in this case, we've got -1.5 as one of my solutions. And on the other side, we've got 5.5 as our other solution. And again, put those in braces. Now the next step is to find that vertex or that turning point in our graph. In this case, it looks like it's going to be up here at our point, and we've got +2, positive 6 as our vertex. So now we're looking for our axis of symmetry, and again, that's going to be a line that cuts right down the middle of the parabola, right through that vertex. In this case, that's going to be x equals 2. And then we have to identify do we have a maximum or a minimum, and in this case, we have a maximum. This is as high as this graph can go, so we have a maximum this time around, and it's as high as it can go at positive 6. Now let's go ahead and take a look at the next example. So here we are at the next example, and it says evaluate the quadratic function using the graph. So we've got f of x is equal to x squared plus 3, and they've got us finding a bunch of different values. So using the graph for a quadratic function to find the answers is pretty easy. So it says f of 0, so we know that since it's inside the parentheses, we know it's going to be the input, so we're looking for the x value. So when the x value is 0, we can see that this point right here is at 3, so we know that's going to be at 3. Find f of 1, okay, so again, 1 is inside the parentheses, so we know that's going to be the input, so we're going to be looking for where x is going to be, and x is going to be 1. Here's our point, so that's going to be 4. So the last question there says find f of x when f of x is equal to 4. So in this case, we've got 4 outside the parentheses, so we know we're looking for our output, so that's going to be our y value. In this case, we've got 2 y values because it is a parabola, so we need to be very careful. So our y value along the 4 line here, we know we already found one of them. That was going to be positive 1. We found that earlier. But we also have a point right here that is also on when f of x is equal to 4. So in this case, our 2 y values are going to be negative 1 and positive 1. So you have to be very careful that sometimes there'll be more than one answer with a parabola. Now let's take a look at the next example. So here we want to evaluate the quadratic function using the equation below, but this time we don't have a graph. But that's okay, we can still substitute in and evaluate just like we've been doing with other things that aren't necessary parabolas or quadratics. So in this case, it says find f of 2, and again, we know 2 is the input because it's inside the parentheses. So we're going to just substitute that in for all of our inputs. So we got f of x, that's going to be equal to, again, we're going to use parentheses here. So 2 squared plus 5 times 2 plus 9. Now again, if we're using our Decimus calculator and we're putting everything in correctly, we shouldn't have any problems because it will follow the order of operations. But if we'd rather do it ourselves, we're going to do exponents first. So 2 squared is going to be 4. 5 times 2 is going to be 10. So then we've got, when we have our f of x, we're going to have that equal to 4 plus 10 plus 9. And if we add those all together, 4 plus 10 is going to be 14. Plus 9 is going to give us f of x is equal to 23. So that's our first one. F of x is equal to 23. Fabulous. The other one that we've got there says, all right, f of f is negative 3. So again, we're going to substitute that in for our input because we got it inside the parentheses. So again, I've got f of x, and we're going to substitute in. So in this case, we've got negative 3 squared plus 5 times negative 3 times, or plus 9. Now we have to be very careful here when following order of operations and making sure that we use our parentheses. If we don't, our Decimus calculator is only as good as the person inputting the data. So in this case, we've got negative 3 squared, so negative 3 times negative 3 is going to be positive 9. So you have to be very careful there, but we end up with 9 plus, in this case, negative 15 plus 9. Now we can't have plus minus, so those obviously aren't going to work out, but when we add these all together, we should end up with f of x is going to be equal to positive 3. So positive 3 is our answer here for this one. That brings us to the end of this problem. It also brings us to the end of the set of notes and this video. If you like this video, throw us a thumbs up. If you love this video, throw us a sub, and we will catch you in the next one.